Alright, so consider the circuit shown below. Find the voltage across each resistor. What is the power supplied to the circuit and the power dissipated or consumed by the circuit? Okay, so you have two sources in here. Here's a 12-volt source, here's a 24-volt source, and okay, so this stands to reason, since this battery has a higher voltage than that, you would assume that the current is flowing in that direction in the circuit. Okay, and actually, so this configuration, when you make a current flow in the opposite direction, this is how you charge this battery. Okay, so if it's a rechargeable battery, when you pass current in the opposite direction, the chemical reaction will go in the opposite direction and the battery gets recharged. Okay. All right, so what is the power supplied to the circuit? Find the voltage across each resistor. Okay, so what we're going to do is we're going to use Kirchhoff's second rule. Here's a closed loop. That means the voltage across each element will add up to 0 around the loop. Okay, so Kirchhoff's second rule says the voltage across each element around the closed loop should add up to 0. Okay, so again, we are saying, let's say the current is in this direction. Okay, so we'll start off here. So the current is like that. I've just drawn it in several places. Okay, what we'll do is we'll start here and then go across each element. Okay, so current is flowing downhill. So when you go across this element, is this still recording? Reflector dropped me. I'm going to assume the recording is still going on. All right, so we are going to start here, and when you go with the current, you have a drop in voltage. So the first term is minus IR5, and then minus IR4. You're going with the current. Then you're going from low to high voltage, plus 24 volts. Then again, minus IR3. The next term is minus IR2 minus IR1. And then when you go across this element, you're going from high to low voltage, so that's minus 12. And all that should add up to 0. Okay. So what you have is, so 24 minus 12 is 12, and then I'll take all the negative terms on the other side. So 12 volts is equal to I times R1 plus R2 plus R3 plus R4 plus R5. Okay. So I is equal to 12 volts divided by the sum of all the resistors. So essentially what this is This is just Ohm's law. The net voltage divided by the net resistance. The net voltage is, these guys are working against each other. The net voltage is 12 volts, and the total resistance is just the sum of all the resistors since they're all in series. Okay. So that's what this thing amounted to. 12 volts divided by, so let's add them all up. They're all kilo ohms. R1 is 10 plus 20 plus 10 plus 10 plus 10. And they're all kilo ohms, so 10 to the power 3 ohms. Okay. And this adds up to 20 plus, that's 60. So 0.2 into 10 minus 3 amps. Okay. 0.2 milliamps is what the current is. Okay. What they're asking us is, what is the power supplied to the circuit? Oh, find the voltage across each resistor. Now the voltage across each resistor is, you know, the current, it's just I times R. Okay. And so the voltage across each resistor is I times Ri. Okay, so I'll just find V1 and you guys can find the rest. So it's I times R1. I is 0.2 into 10 minus 3 amps, and R1 is 10 kilo ohms. Okay, so 2 volts. So the voltage across V1 is 2 ohms, and similarly you can find, so you'll find that the voltage across this is 4 ohms, 2 ohms, 2 ohms, 2 ohms. 2 plus 4 is 6, 6 plus 2 is 8, 8 plus 2 is 10, 10 plus 2 is 12. That's the voltage in the circuit. Okay. What is the power supplied to the circuit and the power dissipated or consumed by the circuit? Okay, so the power supplied to the circuit is I square R, okay, where I is the current in the circuit and R is the total resistance in the circuit. So I was 0.2 into 10 minus 3 amps square, and the total resistance was in the circuit is 60 kilo ohms. Okay, so this is square into 2.4 milliwatts. Okay, that's the total power supplied to the circuit.